the first answer you should give them is the number of hours of sunlight. Different portions of the Earth receive different amounts of sunlight at different seasons. Different portions of the Earth. So whether you're in LA, you're in New York, you're in Canada, you're in Argentina, Australia, depending on the season, depending on the month of the year, you're going to receive different hours of sunlight. Why? The reason is because of the tilt of the Earth's axis. Okay? So you're going to show them, a good picture to show them is something like this. See? So you can see here, this is June 21. And then a few weeks after June 21, on July 4th, the Earth is going to be the farthest from the sun, aphelion. And then you're going to have September, and then you're going to have December 21. And then a few weeks after December 21, on January 3rd, the sun is going to be the closest to the Earth, or I should say the Earth is going to be closest to the sun. That's perihelion. Okay? But the picture I want to concentrate here on is this one. This one here. Okay, so at any time of the day, this shows you the picture on June 21. So on June 21, the Earth is pointing towards the sun. So this is the axis of the Earth. You see it's tilted by how many degrees? We mentioned it the other day. 23 and a half. 23 and a half. Then we can write down some different interesting latitudes on Earth. We can say, what is this latitude here, this latitude here, this one here, this one here, and this one here. And then you can write down any other latitude you want. This is actually, this is going to take us to the next page of the slide. Let's go to the back to the notes, and then I'll come back to here. So you can make, in particular, there are 5 interesting lines that stand out, but you can make any line that you want. One for LA, one for every city of the world. There are 5 major lines on Earth which run from east to west. Let's use these as an illustration. Then we can show this picture. I believe the picture is going to be pretty much the same as what we have here on the board. See, and this one is this one here. And these are the lines here. This one is, this is going to be known as the Arctic Circle. This one is going to be known as the Tropic of Cancer. This one is, of course, the equator. This one is the Tropic of Capricorn. This is the Antarctic Circle. Why are those lines particularly interesting? Because they are all related to the 23.5 degree angle deal, okay? The Tropic of Cancer is 23.5 degrees above the Earth's equator. The Arctic Circle is 23.5 degrees from the 90 degree mark. So you go to 90, you work your way down 23.5, and the latitude of the Arctic Circle is 66.5, okay? And then this is negative 23.5, negative 66.5. So here's what's going to happen. On that day, June 21st, anyone living above the Arctic Circle, you see, you're rotating like that. So if you're a person over here living on the Arctic Circle, you're going to be rotating like this, right? You're going to have no darkness at all on June 21st. Anyone living above the Arctic Circle. You see, you never fall into the darkness. Okay, so now we go back to the notes and then we'll continue. So equator, no matter what time of the year it is, since it's in the middle, You see, equator is in the middle. So half of the equator is in the sun, half the equator is in the dark. So the equator has 12 hours of sunlight. So if you live on the equator, are there severe seasonal variations from month to month? Not much. It's kind of like why you like, some people like living on in Hawaii. It's close to the equator, you know. So it's not going to experience severe winter, severe summer. More or less, it's going to have 12 hours of sunlight throughout the year, okay? But the higher up you go, Tropic of Cancer. The latitude of Tropic of Cancer is 23.5, receives about 14 hours of sunlight at summer solstice, okay? So you see, this guy here, whoever lives at the Tropic of Cancer, most of the day he's in the sun, little less of the day he's in the darkness. So he's in the sun, 13.7 hours daylight. I approximate that to say 14 hours of daylight. But what's going to happen in winter? And in winter, December 21st, situation is opposite. He's over here. He's in the sun very little. He's in the darkness more. So as the Earth's axis is tilting away from the sun, he gets less hours of sunlight. So in December, he gets 10 hours of sunlight, this guy. Arctic Circle is the 66.5. This guy up here, well, on June, he's going to get 24 hours of sunlight. Never see the darkness. And on December, he doesn't see the sun at all. Okay? So he goes over here. You see, he's completely in the darkness in December. He's rotating like this. But then this guy sees the sunlight in December. You see? Tropic of Capricorn is negative 23.5. So that's this one here, down here. Well, the opposite situation is true for them. In June, they get 10 hours of sunlight, 10.3, more hours of darkness. And in winter, of course, we call it winter, but it's their summer, of course, right? 14 hours for winter solstice. It's the opposite of Tropic of Cancer. Antarctic Circle, negative 66.5, is the opposite of the Arctic Circle. Okay? So these, if you look at any globe, you will see that a good globe will have these written on them. Tropic of, you see here, this is the equator. Tropic of Cancer, it's like a dotted line. It goes through, it's pretty close to Mexico City, and it says, Tropic of Cancer, most northerly vertical rays of the sun on June 21st. It goes through Hawaii. Actually, Hawaii is close to the Tropic of Cancer, a little below the Tropic of Cancer. Then it goes through Taiwan, India, Saudi Arabia, Egypt, and goes through the top part of Africa, goes through Cuba, and then back to Mexico City. That's the Tropic of Cancer. Of course, the equator is in the middle. Now, the Tropic of Capricorn down here, it goes through Australia, goes through Madagascar, Zimbabwe, South Africa, kind of near there. It goes through Rio de Janeiro, Sao Paulo, okay, Brazil. So that's the one down here. And then, of course, the Arctic Circle is all the way here. Arctic Circle, you got Norway, Greenland, the countries in the top, you know. And then the Antarctic Circle, the only thing there is Antarctica, down here, you see. How about LA? Where would LA be here in this picture? LA is above the Tropic of Cancer, right? So LA is a little above. So in the summer, we should get a little bit more hours of sunlight than the Tropic of Cancer does. And then in the winter, we should get a little less hours of sunlight than the Tropic of Cancer. You see? So since LA is about right here, you see, our sunlight is more than the Tropic of Cancer, our nighttime less, but then in the winter, opposite. Since we are here, we get less sunlight than the Tropic of Cancer, more darkness. So roughly, I'm going to estimate LA gets about 16 hours of sunlight in the summer. Okay, 8 hours of night. And then winter, opposite. 8 hours of sunlight, 16 hours of dark, okay? So far what have we established? We established the fact that because the Earth's axis is tilted, during the course of the year, we get different hours of sunlight. So if the person tells you, what does that have to do with the tilt of the Earth then? Why does that cause seasons? Well, you tell him, if the tilt of the Earth had been 0 degrees, then every place on Earth, no matter where you lived during the course of the year, you would always get 12 hours of sunlight, no matter where you lived, whether it's June, August, December, November, January, February, March, April, no matter where. You'll get 12 hours of sunlight no matter where you do. So the sunlight might start around 7 a.m. and then go till 7 p.m., you know.
But is it going to be like 4 hours ahead? Or?
The time is still the same. They would be 3 hours ahead. England would be 8 hours ahead. But you would still get the same hours of sunlight. Yeah, exactly. So if the tilt had been 0, every spot on Earth would receive 12 hours of sunlight. That means that's one major reason why your seasons would be similar. You wouldn't change at all, right? Okay, another related reason. Let's say the person is still not convinced that that's the reason for seasons. You'll tell them the angle which the sun's rays hit the Earth change at different times of the year. For example, on June 21st, the most direct rays of the sun shine on the Tropic of Cancer. Why? Because the sun's location in the sky is at 23 deck angle. Remember when we covered the celestial sphere? On December 21, the most direct rays hit the Tropic of Capricorn. So you can visualize a picture like this. So show them, so the Earth's axis is tilted, the sun is there. On June 21, this is what the picture looks like. The most direct rays comes Tropic of Cancer. So the warmest place on Earth on June 21 should be kind of on the Tropic of Cancer. If a person is there, they're going to cast no shadow because the sun is going to be directly overhead at noontime. Okay? Over here, the angles of the sun are coming at a spread out angle, at a much spread out angle. On December 21, the Earth is tilted this way. The most direct rays are coming to the Tropic of Capricorn. Opposite situation. On March or September 21, the most direct rays hit the equator. So here is the point that you're trying to make by saying this. The spot where the most direct rays hit is the hottest place on Earth. The most direct ray. It's not a spread out ray. Because the sun's rays hit the other places on Earth at an angle and are therefore spread out. So a picture like this will help explain what this is trying to say. You see here? So this picture shows you the case on June 21. Since you're tilted towards the sun, if you live on the Tropic of Cancer, the full beam of the sun is coming to you. The sun is directly overhead at noontime. You see the full beam of the sun. So that's why you're going to feel really hot. The full beam, you're receiving the full beam. If you live on the Tropic of Capricorn at that time, is it going to be as hot? No. Look at the same beam of sunlight coming in, same beam coming in. By the time it hits the Earth, look how spread out it is. See how it's spread out? How much of the beam of the sun are you receiving? Are you receiving the full beam? No. You're receiving only a portion of the beam. You get it? This is the best picture to show to illustrate this. It's a best. I can't give you a better one probably. You're only getting part of the beam of the sun. That's why it's cooler there. How about if you live way down here? even worse. The beam is going to come, spread out, and even some of it will miss. And you're receiving much less a beam of the sun. If you live way over there, much less beam of the sun. You see how spread it is? So that's why over here and over there is always cool. Okay? Particularly this one is even going to be more cool because it's tilting this way. You see? So it's going to you're going to miss it completely. You know? So this is a really good picture. So this one here is going to be the hottest place on Earth. This one is going to be spread out. It's less hot and less hot like that. You see?
So the opposite side would be the coldest place on Earth.
Well, you see, this you're rotating this way. Oh, yeah. You're rotating. So during daytime, you're getting full beam. Of course, by the time you get sun, the nighttime you're here. But you have much less nighttime anyway. You have most of the daytime. You see? So not only the fact that if you live here, you're going to have more hours of sunlight, but you're going to have more directed beam of sunlight. You see? So if the person asks you, well, what does this have to do with the tilt again? And then your argument is, if the tilt of the Earth was 0 degrees, then the most direct rays of the sun would always have hit the equator, no matter what month of the year. January, February, March, June, July, August, no matter when, the warmest place on Earth would have been the equator probably, because the equator would have received the direct rays of the sun. You see? But because the Earth's axis is tilted, different places on Earth are receiving the direct rays of the sun, and other places are receiving the spread out rays. Again, if they're not satisfied, there's a third reason. All these three reasons are working together. They're not like three separate reasons. And here is the third one. The path of the sun across the sky as it's rising and setting, rising and setting, rising and setting, that path is changing during the course of the year. For example, if you live on the equator, okay, if you live on the equator, on March or September 21, how is the sun going to rise and set? Well, on March or September 21, the most direct rays hit the equator, right? So if the most direct rays hit the equator, on March or September 21, the sun rises directly east of you, sets directly west. And rises exactly due east of you and sets due west. At noon, it's exactly at your zenith. However, on June 21, the sun rises northeast of you and sets northwest. At noon, it is north of your zenith. On December 21, the sun rises southeast of you and sets southwest. At noon, it is south of your zenith. So if you're in the equator, you're pretty much in the middle of the sky. So basically what's happening is, this is another way to visualize why there are seasons. So if you're in the equator, let's say I'm on the equator, on March or September, the sun is directly rising east, setting west. Okay, that's on March or September. As the months go by, let's say it's March, the sun is starting to go north of me. You see, north of me, like that. By the time it gets to June, it rises northeast of me and sets northwest. And then after June, it starts coming back down, September. And after September, it's south of me, you see. If the tilt of the Earth had been 0, would this phenomenon occur? If the Earth didn't have a tilt? No. If the Earth didn't have a tilt, I'm on equator every day of the year. East of me, west of me, east of me, west of me, east of me, west of me. It would never go north and then back down, you see. If you live in LA, on June 21, the sun rises a little southeast of you. Remember, I think I've mentioned this to you before. For LA, the sun will never be directly overhead for us. So we're always going to cast a little bit of a shadow. So as the months go by and we approach June, we're going to notice that the sun is going more north, 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 north. Eventually on June 21, it's going to be the closest to us that it possibly is, right? So it's going to be a little southeast of you and it sets a little southwest. At noon, it is a little south of your zenith. However, on December 21, and we just passed December months, you know, that's why it was so cold, the sun was very much south of us. Okay, very much south of us. At noon, it is a lot south of your zenith. The path of the sun changes a lot during the course of the year. So that's your third argument. So here's the three arguments put together in the same sentence. So you're somewhere with your friends, you ask them, what's the reason for seasons? Let's go back to the story. They say, oh, it's because the earth is sometimes close, earth is sometimes far. You tell them, no, it's not. And then you show them that the earth is close in January and far in July. And then they say, what's the reason then? You say it's the tilt. Then they say, how does the tilt cause seasons? Here's your three arguments in sentence after sentence. The tilt causes the days of the hours of sunlight to change during the course of the year, number one. Number two, the tilt causes different portions of the earth to receive the direct rays of the sun. And then three, the tilt causes the path of the sun to change in the sky during the course of the year. The path changes, you see? Those are the three reasons summarized together. And as a matter of fact, I have a picture that kind of summarizes all three. Watch this picture here. You could show them this picture. And all this picture, what's cool about it is it takes all three reasons and then puts it into one. You see here, on December 21 or 22, okay, here's what's going to happen. I love this one. The sunrise is taking place at 8:15. You see how the path of the sun is very, very low in the sky if you're in LA? The picture is meant for kind of LA people, okay? So it goes like that, goes like that, goes like that. So sunrise is 8:15, sunset is 5:30. That's about how much? About 4, 5, about 9 hours of sunlight. So the other reason, you see how the rays of the sun are spread out? So if you're the house, you're only going to receive a portion of the sun. That's the second reason. And you see how it's low in the sky? And the path is very, very arced compared to you. That's the third reason, the path of the sun. Now, if you go over here, on June, watch this one. Sunrise, 5:25, 8:30. Ooh, so that's going to be a lot of hours of sunlight. 6, let's see here, 8, that's 12 hours plus another 3, about 15 hours of sunlight, right? So the other reason, you see how the rays of the sun are not spread out? You're getting directed rays, second reason. And you see how the arc is not very low from your zenith. You see here? It's almost directly over top of you. Okay, let's see what are these two showing. These two are showing the situation in September and March. So it's kind of in the middle between these two, you see? This is very low in the sky. This is kind of low, March or September. And in June, it's a little low. If you get this picture, you can explain to anybody why we have seasons. It's all right here, okay? All three reasons is right there. Picture, you know the saying, the picture tells 1,000 words. That's it. You just show someone like this one, and then they should get it. If they don't, explain it to them. So all of these stem from one fact, the tilt of the Earth's axis. So now we go to next interesting thing, which is the phases of the moon.